Hello, this is Dr. Polig, and I'm talking about HARC Physics, uh, Module 6 tab, and this is actually part C, which is on pulleys. Now, this part on pulleys is actually not in your textbook, so but I thought pulleys are important enough and a great engineering application of what we're learning in Chapter 6 having to do with forces that it was a great thing to do. So I went ahead and added this part to the lab. Now on page 7 of the lab, we have the most simple kind of pulley, which I'm going to draw it here. This is, again, we're dealing with the frictionless pulley system, which we assume. And here's our pulley. And on one side of the pulley is connected to a rope, and there's a mass hooked up to that right here. And the rope holds the mass, which is connected to the pulley, and the pulley serves to redirect the tension over here to some angle, and we actually hold on to this. We hold on to the tension, and if we hold it with some tension T, which is actually, as we know, a force. If, let's suppose that the weight of this mass is such that the weight times the mass is in English units 100 pounds, just to keep it easy. Now, if we look over here, the rope that's pulling up on the mass has tension. We'll call it T. Now, the weight acts down. As we do in physics, we looking at Newton's second law. We look at the sum of the forces in the y dimension here around the mass. We have two. We have T1, which acts up, and the weight, which acts down. That's why we give it a negative sign, and that equals 0, because the weight is not accelerated up or down. It's in a static condition, a static equilibrium condition. It's not moving. Therefore, T1 equals the weight, which is 100 pounds. Now, this T1 is the same tension as over here. And so, the pulley serves as a mechanism to redirect this vertical force T1 into some angle. And as long as we hold this tension in the rope with a 100-pound force, we will succeed in keeping the mass stationary. So this is the most simplest kind of pulley system. Notice that we're holding 100 pounds of weight. That is, we hold 100 pounds of weight and we hold 100 pounds of mass. The ratio of those two is 100 to 100, or 1, when we call this a mechanical advantage of simply 1, which means for every pound that we're holding, we have to supply a pound of force. Now, if on the next most complicated pulley system, which is on page 8, draw that now. This pulley system has two pulleys. There's the first pulley is tied to the ceiling, right, of the roof. We have another pulley directly below it, and we have a mass that's suspended below this second pulley of mass M. And the rope is tied up here at the ceiling. It comes down to the second pulley, comes up top pulley, and we hold it with some tension force T. If we analyze this system of forces holding the mass, we have a weight that acts down, and let's again call that 100 pounds. There's two ropes now holding this pulley. Notice that this bottom pulley is fully suspended by two ropes. We'll call that T1 and T1. Notice that these two tensions are the same. They will be because of the symmetry of the problem. They will equalize themselves. Again, this top pulley only serves to redirect this tension force over here that we can hold. So for us to hold this. So by holding this tension force over here, we can hold this second second pulley holding the mass. Let's analyze this. The sum of the forces in the Y. There's two T1 tensions acting up, and then we have one weight acting down. That's given a sign acting down. That's equals 0. So we have 2 T1 equals W, or T1 is equal to W over 2. So if the weight is equal to 100 pounds, T1 force is half that, or 50 pounds. 50 pounds. So the force that we have, the tension force that we have to hold on to, is the same as T1, which will be 50 pounds. And so notice that we can, in a 50 pound, by holding 50 pounds of force, we can actually suspend something that's double that, 100 pounds. And so the mechanical advantage here is the weight we can hold by what we actually are holding, or 2. That's a mechanical advantage of 2. So, so I hope you can, this is clear how this single pulley system and a double pulley system work. What I want you to do for the lab is to come up with your own design for a pulley system with a mechanical advantage of 3, and then a mechanical advantage of 4. So hopefully this will give good insight as to how this would be done. Okay, so long.